Hi, it's Nicole, the math lady, and today's lesson is going to be on angles. So, I always like to start with definitions. So let me set this up by giving you a few definitions. So the first word I want to share with you is the word plane. Now, I'm not talking about an airplane. I'm talking about a plane in math. A plane in math means a flat surface. So it could be my board is a plane, and my tabletop is a plane. Or you can see, the flat of my Mickey Mouse blocks is a plane. Now, on a plane, you can have lines. And let's draw two sets of lines for you here. Remember, lines have arrows on the ends because they go indefinitely in both directions. Now, these lines, notice that hopefully I drew them straight, but you know me and drawing straight, it's not my strong suit. But let's just say that they're straight, okay? If these lines are perfectly straight and perfectly equidistant from each other, that means they are never going to intersect. This line's going to go off in that direction, and this one's going to go off in that direction, and they're never going to touch. Same thing happens on this side. When that happens, we call these lines parallel lines. Okay? Parallel lines. Now, what happens if I didn't draw them perfectly equidistant from each other, and maybe they're going to intersect at some point? Let's say I drew one line like this, and another line like this. I'm going to keep this one going. Ooh, there we go. Those are not parallel lines, right? They are intersecting lines. So, intersecting and parallel. Now, I want to get more specific on these intersecting lines. Let's just take a look. Like, where in real life do we have intersecting lines? Well, notice, I went to my kitchen and I found the scissors. And notice, in the scissors, we have intersecting lines. We have one line here and one line here, and they intersect right at that point right there. Pretty simple. What about parallel lines? On this board, we have parallel lines, right? This is a line here, and this is a line here, and these lines will go off indefinitely, and they're never going to intersect, so they're parallel lines. So parallel lines, intersecting lines are around us everywhere in life. But let's take a closer look at these intersecting lines. If I had lines that intersected, that cross, that when they cross, they created, let's see, it's not so straight. Let's try it again. You know me and the straight lines. Hey, you know what? I'm going to use an actual ruler. Hey, what a concept. Okay, let's say, there we go. And perfect. Okay, let's say when they crossed each other, they crossed and they made perfect angles, perfect square. They crossed exactly such that a square was created. There's a special name for these kinds of lines. They are called perpendicular. Perpendicular lines. Okay. Now, this one here, they're not at that nice right angle. This is an intersecting line. They're both intersecting, but this one's name is called oblique lines. That's a Q, O-B-L-I-Q-U-E, meaning they intersect just like this one does, but not at these perfect angles where, or a perfect intersection where they both form a square here. Okay, so we've got perpendicular, we've got oblique. Those are both intersecting lines. So take a look at what I have on the board. I have 3 different angles on the board. So when I say angles, essentially I mean when lines intersect, angles are formed. And technically here we're using rays, right? Because we have an endpoint on one side and a line that goes indefinitely on the other, and an endpoint here and a line here. So we have formed some angles. And these are, there's some words I want to introduce to you regarding angles. So first, we have the endpoint that joins the angles. We call this the vertex. There you go. So we got a vertex there, a vertex there, and a vertex there. And there are different ways that we can call these angles using the vertex. So let's say we wanted to call this vertex B. And that's all we had. We could simply just call this angle, the entire angle, angle B. If that's all the letters we had, we would just say angle B. But let's say that we had a point here and a point here on the ray. This was called A, B, and C. We could call this angle ABC. And I'm going to write it for you how we note it, an angle ABC. Over here, we just called it angle B because that's all we had. I want to show you one more thing regarding how we name angles. Let's say this one, there was a D, there was an E, and there was an F. So we could call that angle D, E, F. But what I want to show you is what we can't call this angle. We cannot call this angle EDF or FDE. That vertex always has to be in the middle if we're going to call three of the letters. So remember, DEF is okay, but in this situation, EDF, FDE doesn't work. The vertex always has to be in the middle. So now I want to talk to you about these angles and some more names of the angles. So let's start with our one in the middle. Remember, this is the one that formed a square when the two lines intersected. So with that, we can draw a little square right there to show that they have perfectly lined up. We call this kind of angle a right angle. And generally, a right angle, if I got my protractor out, would measure 90 degrees. Now, let's go over to this one. This one is not 90 degrees. It is less than 90 degrees. So we call this an acute angle. And the way I try to remember it is I think, oh, it's smaller than 90. Oh, it's so cute. Look at that. It's such a cute angle. It's smaller than 90. Usually we call things that are cute like little tiny dogs, acute. Now look at this one. This one is more than 90 degrees. So he's not a cute one, he's a big one. So we call this angle an obtuse angle. So let's practice that. Here I've got some angles on the board. First of all, do you see any perpendicular lines? Any right angles that I've drawn? I don't see any. And remember, if I had, you'd see that little square to show me that we have a right angle. So this doesn't have any right angles. What if I asked you to find an acute angle? Do you see any really cute angles up here, smaller than 90 degrees? Ah, I see them. Well, how would you name that? Well, remember, we always want to put that vertex in the middle. I see one at A, B, C. So angle ABC is acute. It's an acute angle. What about an obtuse angle? Do you see any obtuse angles that are more than 90 degrees? Yep, I see one. How about here? Remember, the vertex goes in the middle. CBD, angle CBD is an obtuse angle. There you go. Let's try another example. So here we have a shape. Let's look for angles. First, do you see any right angles? Remember, right angles always have that little square. And yep, I see how many? 2. Let's name them. The right angles are angles YXW. YXW, that's 1. What about this one? XYZ, right? This one here. Angle XYZ Y, Z. Those are your right angles. Do you see any acute angles? They're so tiny, they're cute. They're less than 90 degrees. I see one. Look right here. This one. W, Z, Y. So W, Z, Y is acute. And do you see any obtuse angles in this shape? I do see an obtuse. It's right up here, the Y, right? And how do we name that? X, Y, Z. Angle X, Y, Z. And there you have it. You've learned all about 3 different types of shapes, perpendicular lines, obtuse lines, all sorts of stuff. So I think you pretty much have it. We'll do some more practice exercises just to make sure you got it. But that's it, your lesson for today. You did a great job. I'll see you soon. Bye-bye.